Hello students, today we'll see how to solve geometric progression using which one is convergent series, which one is divergent series, and other stuffs. Okay, first of all, this is the third part of the geometric progression, that is GP. For a series to become convergent, R must be less than 1. For a series to be convergent, R must be less than 1, and for that reason sum of n terms will be a into 1 minus r to the power n divided by 1 minus r. For a divergent series, r is greater than 1, and therefore the sum of n terms will be a r to the power n minus 1 divided by r minus 1. So these are the only differences when you are using convergent series and divergent series. So for convergent series, r must be less than 1, and for divergent series, r must be greater than 1. And if the series is convergent, it will have a sum to infinity, that is a divided by 1 minus r, that is a divided by 1 minus r. Okay, so if the series is convergent, it will have a sum to infinity, that is a divided by 1 minus r. So here the terms, as we know, that is the first term a, second term a r, and third term a r square, fourth term হচ্ছে a r cube, and these goes like a to the power r, a r to the power n minus 1, this way. And to find out the common ratio in any of the terms, you must divide second term by first term, and third term by second term, or fourth term by third term, in this way. That means the second one gets divided with the first one, or third one gets divided with the second one, this way. Okay, so this is exercise 3C from Peng Pure Mathematics. So the series is given, that is 1 by 2, 1 by 4, 1 by 8, and 1 by 16. So for the series to be convergent, we know r must be less than 1. Therefore, to find r, second term must be divided with the first term, and the answer is 1 by 2. And the answer is 1 by 2. So the series is convergent. Okay, so the series is convergent. Okay, have a look. Number 3, that is 5 by 2 plus 5 by 4 plus 5 by 8 plus 5 by 16. So in this case, the same goes, that is r equal to second term divided by first term. So the value of r is 1 by 2. This is also less than 1. So this series is also convergent in this case. This is question number 6, and the numbers are 1000, 500, 250, and 125. So to find out r, 500 must be divided by 1000, and the value is 1 by 2. So this series is also convergent as well. Okay, have a look at number 7. Might be different from the other series, that is 1 plus x square plus x cube, where the modulus of x is less than 1. So since the modulus of x is less than 1, r must be less than 1 too, and the series is convergent as well. And the series is convergent as well, since the modulus of r is less than 1. Okay, so let's come to the question number 2, and here from the book it was asked to find out the sum to infinity of the series, that is the sum to infinity of the series. Okay, at first you need to find r, that is the second term divided by first term. So the answer is 2 by 3. So the answer is 2 by 3. Now for the sum to infinity, that is a divided by 1 minus r. So 2 is the first term and 1 minus 2 by 3. So the answer comes 6. So sum to infinity of the series is 6. Number 4, 81 minus 27 plus 9 minus 3. Once the value is positive, the next value is negative, and then again positive, and then again negative. Okay, so in this case the r will be minus 27 divided by 81, since the second term of the series is minus. So the second term, that is minus 27, gets divided with 81. So the value of r is minus 1 by 3. Okay, now, therefore, the sum to infinity is a divided by 1 minus r. So, a equal to 81 divided by 1 plus 1 by 3. So, 60.75, or you can keep the answer in the fraction or mixed fraction anyway if you want. So, the answer is 60.75, which is the sum to infinity of this series. Okay. Now, come to the next point, that is math number 3. In this question, the third term was given as 9, sixth term was given as 2 by 3, 2 whole 2 by 3. Okay, for the third term, the formula is ar square equal to 9, and for the sixth term, it is ar5, ar to the power 5 equal to 8 by 3. Okay, so to find out r, you must divide this sequence with this sequence. So ar5 divided by ar square equal to 8 by 3 divided by 9. Okay, look, the corresponding values are divided. So aa gets cut, and r5 divided by r square, that is r cube, equal to 8 by 27. So cube root equal to r equal to cube root 8 by 27, and the answer is 2 by 3. So using this value of r, you will find out the first term, that is ar square equal to 9, a divided by 9 r square. So put 2 by 3 in the value of r square, and the value of the first term is 81 by 4. And now the sum to infinity of the series, that is a divided by 1 minus r. So a divided by 1 minus r equal to 81 divided by 4 by 1 minus 2 by 3. And so the sum to infinity of the series is 60.75. Okay, so this is the sum to infinity of this particular series. Okay, now let's come to question number 6, that is the series given log 6561, log 81, log 9, and log 3. The same procedure you need to follow, that is r equal to log 81 divided by log 6561 equal to 1 by 2 is the answer. You can put the value directly to the calculator, that is log 81 divided by log 6561, 1 by 2. So the sum to infinity of this series, that is a, what is the value of a? So the first term is log 6561. Okay, so put log 6561 divide by 1 minus 1 by 2. The value of r was 1 by 2. So log 6561 equal to 1 minus 1 by 2. And the value of sum to infinity is 7.63. That is that is to 3 significant figures. In the question, it was asked to keep the answer in the form of 3 significant figures. That is 7.63. Okay, so the next math, that is the question was given, that is the product of the first 3 terms equal to 9, equal to 1, and the product of the last 3 terms equal to 64 divided by 7 to 9. So a cube r cube equal to 1, and here a cube r to the power 9 equal to 64 by 7 to 9. Okay, so using these two formulas, or using these two expressions, you need to find out the value of r, the possible value of r, and the possible values of sum to infinity. Okay, so a cube r to the power 9 divided by a cube r cube equal to 64 to the divided by 629 divided by 1. So r6, because a cube gets cut, and r9, r to the power 9 divided by r to the power 3 is equal to r to the power 6. So r to the power 6 equal to 64 divided by 729, and the value is plus minus 2 by 3. The question is why the value is plus minus 2 by 3. As we know, for any even root, there are two possible values. One is negative, one is positive. And here, since the power is even, the root value must be plus minus for the given value. So plus minus 2 by 3 is the possible values of r. That means r might be positive 2 by 3 or negative 2 by 3. Okay, then using this value of r, you need to find a and then sum to infinity. So at r equal to 2 by 3, you can use the first equation or the second equation as you like best. So r cube equal to, so a cube, r cube equal to 1, and a cube equal to 1 by r cube. Cube root 1 by r cube. So put the value of r, that is 2 by 3, in this expression, and the value of a is 3 by 2. Okay, then the sum to infinity of the series is a divided by 1 minus r. The value of a is 2 by 3, and 1 by r is 2 by 3. So the value of sum to infinity is 9 by 2. Okay, then using the negative value of r, you again need to find the value of a, and this comes like minus 3 by 2. Okay, the same procedure, but you need to put a negative sign before the value, that is 3 by 2. And using this value, find out the sum to infinity, that is a divided by 1 minus r. The value of a is minus 2 by 3 divide by 1 minus 2 by 3, that is minus minus gets plus, and the value of this series is minus 9 by 10. So using the possible values of r, that is 2 by 3 or minus 2 by 3, we got two possible values of sum to infinity of this series. And this is how you need to attempt the convergence series maths of GP series. Okay, I hope you are clear with the video. If you have any questions regarding the concept, you can let me know on the comment section. Thank you.